Hi! Before we begin today's problems, I want to return a simple but powerful question. How do we move forward wisely? So in the last few questions, we saw different way of thinking. The backtracking teaches us to explore carefully, but this question teaches us something different. It's not about explore every road, it is about find a closest necessary steps. So today, let's study one elegant ideas, the greedy range expansion. So the problems gives us an array called names. So each name I tells us the maximum distance we can jump from index I. So our goal is not only to reach the last index, our goal is to reach it with the minimum number of jumps. So this is the key difference. If the problems only ask whether we can reach to the end, that would be easier. But here we must ask, among all possible movements, which path use the fewest jumps? So the problems is really about efficiency, not just the possibility. So let's look at the example. We can see at the index 0, the value is 2. So that means it can jump to index 1 or index 2. But there is the important point is we should not jump blindly. We first absorb the whole reachable range. So inside the range 1, 2, inside 1 can reach index 4, while index 2 only can reach index 3. So the best feature comes from index 1. So that means we only need 2 jumps from index 0 to index 1, then from index 1 to the end, right? So here is a core ideas. The one jump create one range. So for the code demo is these 2 lines. So inside this range, we search every possible position and keep update the farthest place we can reach. So that's why the algorithm is called greedy. It does not care about every detailed path. It only cares about one question. From this current range, what is the farthest future we can open? So these lines means we have finished checking all position reachable by the current number of jumps. So now we must count one more jumps and move the boundary to farthest. So this is the soul of the problem. So now the code become clean. So we use 3 variables. The jump means the minimum jumps count so far, and the current end means the end of the current jump range, and the farthest means the farthest index we can reach while scanning. So each index we update, and we do not need jumps again. So now let's compare the question 55. If you are interested, you can do that. That question asks, can we reach to the end? But this question is talk about what is a minimum number of jumps. So this question is check the range boundaries. So the memory rule is 1 jump, 1 range, and scan the farthest future when the range ends at 1 jump. So from the beginning, we asked that how do we move forward wisely? So now we have the answer. Wisdom is not always move faster. Sometimes wisdom is seeing further before we move. So that is the philosophy of these questions, and I hope you like these questions. Thank you very much.